Today, we will be conducting the Cocoa Collisions simulation from Lesson 3 of MyStars Unit 7.3 in order to investigate the question, how does temperature change? In this simulation, we will model how the temperature of a cup of hot cocoa changes over time. The cocoa starts hot, but cools over time to about the same temperature as the surrounding air. In this system, the air and cocoa are made up of molecules. There are many air molecules, an entire room's worth, and fewer cocoa molecules, just a mug's worth. The air is cooler than the cocoa, meaning that the air molecules are moving around less. Since the cocoa is hot at the start of the simulation, its molecules are moving a lot. However, they will slow down as the cocoa cools and eventually reaches the same temperature as the air. To simplify our model, we'll assume the cup is really well insulated, so that no energy from the molecules can be transferred through the sides of the cup. Energy is only transferred where the air and the cocoa meet. If we were to zoom into a cup of hot cocoa, we see a layer where the liquid cocoa molecules and the surrounding air molecules meet. We will focus on this layer in the simulation since it is the only place in our model that energy can be transferred. All the air and cocoa molecules floating around this area contain some amount of energy, and the amount of energy is related to how fast the molecules are moving. As the molecules float around this area between the cocoa and the air, they sometimes crash into each other. The layer where the liquid hot cocoa and air meet and crash into each other we will call the collision zone. When molecules from the air crash into molecules from the hot cocoa, they can transfer energy to each other. During this collision, the faster moving molecule passes energy to the slower moving molecule, and they both leave the collision with the same amount of energy. In the cocoa collisions activity, we will be simulating the transfer of energy between the air molecules and cocoa molecules over time. We will then calculate how these collisions, and thus transfer of energy, changes the temperature of the air and the temperature of the cocoa.